Alright, let's go ahead and look at the problems in this review set. So first of all, on number 1, you're finding a distance between 2 points. And so there's a formula. It's d is equal to the square root of x sub 1 minus x sub 2 squared, quantity squared, plus y1 minus y2, quantity squared. And so let's go ahead and call this our first point, x1, y1. And this will be our second point, x2, y2. Or we can say x sub 2, y sub 2. And let's plug those in. So you may notice in the book the formula is actually reversed. It really doesn't matter whether you have the x1 or x2 first. We're just subtracting the two x values. So it'll be negative 4 minus 3. And then that's squared, plus we're going to subtract the y values. And let's see, it's going to be 1 minus negative 6. And that's squared. So we're going to get the square root of negative 7 squared. Well, this is negative 7 squared. And when you square that, you do get 49. And this is also, well, this is going to be 7 squared, which is 49. And so you get the square root of 98. Now, this is not simplified because it has a perfect square factor. In fact, we can see we have two 49s in this number. We can write this as the square root of 2 times the square root. Actually, we usually put the square root first, perfect square. So that would be the square root of 49 times the square root of 2. So simplified, this radical is 7 square roots of 2. Now I just wanted to say something about this formula. It's not that hard to derive. Let's go down to the bottom here. We'll look at that one later. Alright, so if you have 2 points, x sub 1, y1, and x sub 2, y sub 2, and you want to find the distance between the two, basically what's going on here is you can always make a right triangle. And this distance here is found by subtracting your x values. So that's x sub 2 minus x sub 1. I probably should say x1 minus x2 since that's how I did it before. Because we're going to square it, it doesn't really matter if it's positive or negative. And this distance here, that's our y distance, is found by subtracting the y values. So y sub 1 minus y sub 2. And again, I probably should reverse these because that would make these positive, but again, it doesn't matter because we're going to square it. So now you have d squared is equal to x sub 1 minus x sub 2 squared plus this side squared. And you can see if I solve for d, you have the distance formula, which I used up above. So let's go ahead and look at number 2 now. It says, write the standard equation of the circle with the given radius r and center C. Now the formula is x squared plus y squared equals r squared. I should say that's the equation of a circle that's centered at 0, 0. So I'll show you that down here. Oops. You can see that if you have a circle with a radius of r, and you've got this point xy, you could choose any point around the sides here. But this is x, this distance from here to here, that's the x value of the coordinate, and this would be y. And using Pythagorean Theorem, you have x squared plus y squared equals r squared. It was similar to what we did here. We were also using Pythagorean Theorem. All right, so let's go back now and use it, this formula, this equation. So you can see in our case, r is 20, so we're going to have x squared plus y squared equals 20 squared. And so the equation would be x squared plus y squared equals 20 squared, that's 400. Let's move on to number 3. Oops, let me see if I can get this a little better focused. All right, so here you can see that 25 is equal to r squared. And you can take the square root of both sides, you'll get plus or minus the square root of 5. But keep in mind a radius is going to be positive because it's a distance. Radii is always positive. And so we just need to graph a circle that's at the origin, because notice it's in this form. So it's at the origin with a radius of 5. The easiest way is just put some points around the circle at 5 units from the center. And let's see, it's easier to do this on the computer. It's going to look something like that. So this is your graph. Let's move on to number 4. Now I'm not going to show you where this equation comes from, but it's very similar to what I did earlier for a circle. It's just the circle's not centered at the origin. It's actually at some point, we call it HK, and the standard form of a circle is x minus h quantity squared plus y minus k quantity squared is equal to r squared. So you can see here that your h is going to be 4 and your y is going to be 6, and you have a radius of 7. So we need to find the circle that's got a center at 4, 6, and that looks like that's this one here, with a radius of 7. 1, 2, 3, 4, 5, 6, 7. So that would be the one. All right, for the second one, you can see the only thing that's changing is the signs. So this is really like x minus -4 squared, which would tell me my h is a negative value. It's really just the opposite of what's here. It's a +4, it'll be a -4. Our center is going to be at -4, -6. And again, all of these circles have a radius of 7. This is our r squared, so 7 squared is 49. All right, so let's see, that would be -4, -6, that's this one here. And so we want to write x plus 4 squared plus y plus 6 quantity squared is equal to 49. This one here, we're going to be at -4, 6, again with a radius of 7. And that's this one here. And finally, A. I'm not going to do any work. I'm just going to plug it in because it's got to be the right answer. It's only one left. But you can see we should be at 4, -6, and sure enough, that's where our center is. All right, last problem. I think we're good there. So it's very important that you can work with fractions, and we talked previously a little bit about fractions. Notice this is a fraction divided by another fraction, or this is what we call a complex fraction, where you have a fraction within a fraction. But really, this is just a division problem here. And we know that we can multiply by the reciprocal. So this is negative 24 over 8, or negative 3. And you will see in this course, you're going to be doing a lot of problems where you have to work with fractions in this way. All right, that's it for this video.